Welcome to episode 84 of George's Random Astronomical Object. Every episode, I run a random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and talk about what makes the object so interesting to astronomers. So let's now run the random number generator.
One, three.
This episode's coordinates are 22 hours, 37 minutes, 58.7 seconds right ascension, and negative 22 degrees, 38 minutes, 40 seconds declination. These coordinates point to a star in Aquarius called HD 214362. This is a large red star that many people would be tempted to initially call a red giant. However, astronomers technically refer to it as a horizontal branch star, which is similar to, but not quite the same as a red giant. Stars like the Sun fuse hydrogen into helium in their cores, but when their cores fill up with helium, they expand and turn red to become red giants. Red giants fuse hydrogen into helium in shells around their helium cores, but at some point, the pressures and temperatures within the cores of red giant stars will get high enough that they can trigger the fusion of helium into carbon and oxygen. At this point, the stars will change color, but will not change brightness. In the plot with brightness on the y-axis and color, or surface temperature, on the x-axis, these stars lie on a horizontal line, which is why they're called horizontal branch stars. It's not the best name when you think about it, unless you're really into graphs or something. Anyway, HD 214362 is one of these horizontal branch stars. It's actually a fairly ordinary looking horizontal branch star too. It's large and red, but so are most other horizontal branch stars. At a distance of 628 light years or 499 parsecs, it isn't particularly close to Earth, so it doesn't look particularly bright in the sky. It isn't even visible without a halfway decent amateur telescope, and I don't think a somewhat experienced amateur astronomer would be able to identify it without a lot of assistance. It also isn't in the binary star system, at least as far as I know, and no one has found any exoplanets or anything else orbiting it. It also doesn't vary in brightness or produce weird radio or X-ray flares or anything exciting like that. So HD 214362 is just an ordinary looking red horizontal branch star, and in fact, based on its appearance, it's rather boring. And you would have thought that I should have run the random number generator again to try to find the coordinates of a more interesting object. However, HD 214362 is moving in a completely random direction, which makes it much more interesting than your average everyday horizontal branch star. The Sun, and most stars near the Sun, are part of the disk of the Milky Way, and they travel more or less in roughly circular orbits around the center of our galaxy. Additionally, most of the interstellar gas in the Milky Way is also located within the galaxy's disk and also travels in roughly circular orbits around the center of the Milky Way, and this includes all of the cold interstellar gas clouds that stars form from. When stars do form from these cold gas clouds, the stars end up retaining the gas cloud's momentum and travel in the same direction. HD 214362, however, has a really elongated orbit. Astronomers use a quantity called eccentricity to describe the elongation of the orbits of various astronomical objects, although the word eccentricity might as well be used in its everyday sense, i.e. peculiarity or strangeness, to describe the orbit of this star. The eccentricity for a circle is 0, while the eccentricity for an extremely elongated ellipse is close to 1. For reference, the Earth's orbit has an eccentricity of 0.0167, which means that it's very close to circular. The eccentricity for the orbit of HD 214362 around the center of the Milky Way is about 0.95, which is really stretched out. This is actually more extreme than the eccentricities of the orbits of a lot of comets in our solar system, although it is close to the eccentricity for the orbit of Halley's Comet. Another way to think about HD 214362's orbit is to look at how it varies in distance from our galaxy center. HD 214362 gets as close as 6,500 light-years to the center of our galaxy before traveling further than 200,000 light-years away from it. In comparison, the Sun more or less orbits the center of the Milky Way at around its current distance of 26,700 light-years. The eccentric orbit of HD 214362, where eccentric could still mean elongated or just generally weird, also takes the star outside the disk of the Milky Way into its halo. In fact, HD 214362 is just barely gravitationally bound to our galaxy. So the big question is, what happened to cause HD 214362 to orbit in such an eccentric way? That is not immediately clear. One possibility is that the star originates from a much smaller galaxy that was gravitationally pulled apart when it passed too close to ours. Another possibility was that the star was ejected from a globular cluster orbiting in our galaxy's halo after that star had gravitationally interacted with some of the other stars in that cluster. A third possibility is that the star was ejected from the center of our galaxy after gravitationally interacting with the other stars in that region. In any case, HD 214362 and other stars like it are some of the very few individual evolved red stars that astronomers can identify as very likely originating from somewhere other than our galaxy's disk. Astronomers like being able to find stars like these because they provide new insights into the nature of stars from other parts of our galaxy, or from other galaxies altogether. And this is why astronomers will continue to focus their research efforts on HD 214362. And that's my explanation of what makes HD 214362 a very random star, and the location on the Earth's surface corresponding to the position of HD 214362 in the sky is about 2,300 kilometers east of Rio de Janeiro in the Atlantic Ocean. This location is not quite within the mid-Atlantic ridge, which is okay, because I would have had problems associating the seismic activity and spreading of the Earth's crust at the mid-Atlantic ridge with the eccentric orbit of HD 214362. The website for this podcast is www.randomastronomicalobject.com. You can go to the website to download episodes of the show, read information about the astronomical objects, view images of those astronomical objects, look up additional reference information, and send me random feedback. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Endy at www.sasha-endy.de, and the sound effects are from the Freesounds project at www.freesounds.org. Thanks for listening.